Yay for today, we get to talk about sector area, and your learning target is I can find the area of sectors. So let's talk about the sector of a circle. So the sector of a circle, so that sector is the first blank there. The sector of a circle is a part of a circle bounded by two radii and an arc that connects them. Okay, so this little green section here that I have on my notes, that is called the sector. Okay, it's bound by the two radius here, and the arc that connects those two. All right. Now, if we were to talk about trying to find the area of a circle, we all know that the area of a circle is given by pi r squared. Okay, that's something that we learned quite a long time ago. But if I were to ask you what the area of a semicircle was, I bet a lot of you guys could guess that that would just be half of it, right? Half of pi r squared. And even if I were to ask you what is the area for the quarter of a circle, I'm sure a lot of you could even guess that that's going to be 1/4 pi r squared, right? These would be the formulas in order to find the area of a circle, semicircle, or quarter circle. Now, we can use a formula similar to this to find the area of any sector, because if you think about this, this is 180 degrees right here out of 360. If you reduce that fraction, you get 1/2. This section is 90 degrees. Divided by 360 is 1/4. So the formula for finding the area of a sector is just that same exact thing. Its area is equal to m degrees, which is the arc, the area of the arc, divided by 360 times pi radius squared. So we're going to practice that little formula there with example 1. It says find the area of each sector and round our answers to the nearest tenth if we need to. So let's go ahead and we're going to write out the formula right here. We've got m, which is the degree, the arc, or the central angle that we're using, divided by 360, all times pi radius squared. And so we see a lot of this is already written down here for us. All we have to do is just substitute numbers and solve. The measure of the angle that we're finding right here is 285. So 285 divided by 360 times pi times radius, which our radius is 14 centimeters, squared. And all we have to do then is go to our calculator and punch these numbers in. We're going to go ahead and I'm going to go over here. Take our fraction 285 divided by 360. We get this decimal right here. And we need to multiply that by pi times radius, and our radius is 14 squared. And we get 487.5 if we round it to the nearest tenth. So the area of this sector is 487.5. We're talking about centimeters squared. Now the area of a segment is a little bit more difficult. It's not hard, but it's a little more difficult. It's a little more complex. This is the area of a segment is the area bounded by a chord and an arc. Okay, so this segment right here, this is what we're talking about. We're talking about the area of this segment. It's the area bounded by the chord and the arc. Now the area of a segment, the way that we can figure this out, is equal to the area of the sector minus the area of the triangle that is left out by this segment. So all we really have to do is just find the area of the sector, subtract the area of the triangle, and you'll find the area of the segment. So let's go ahead and do that in an example. Example 2 says find the area of the segment, round our answers to the nearest tenth if we need to, right? So we're going to do that. We remember the formula is the area of the sector is equal to the area, sorry, this is segment here. The area of the segment is equal to the area of the sector minus area of the triangle. Okay, and so we just need to find what the area of the sector is and find the area of the triangle is, subtract those, and we'll find the area of our segment. So let's go ahead and do that. We've got the sector area, and remember the formula for that is A equals m divided by 360 times pi times radius squared. And this is just putting in some pieces of information. Our degree, our m, is 120 divided by 360 times pi times 8 squared. To figure that out, we just get our calculator out. 120 divided by 360 times pi times radius squared is 67.0, really? So 67 units squared. And now we have to find the area of the triangle. And that, remember, is given by the formula 1/2 times the base times the height of the triangle. Alright? And so we have a little bit more work that we need to do in order to try and figure out what the base is and what the height is. Well, 1/2 is going to stay the same, but we need to figure out what is that base. Okay? And what we can do is we can build a right triangle out of this little triangle over here in order to use that information. Remember, if we go back to a unit quite a while ago, we had these 30, 60, 90 degree triangles, and the small side, or the hypotenuse, was twice the small side, and the long side was the small side times the square root of 3. And if you see here, we cut 120 in half, we're just going to have a 30, 60, 90 triangle. And remember that small side, if you looked back at that sheet there, the small side was half of the hypotenuse. Okay, so our height is just going to be 4. And our long side was the small side times the square root of 3, so 4 times the square root of 3. I just got these two numbers using what I know about special right triangles for 30, 60, 90 triangles. Okay, all I did was plug in those numbers. So now all we have to do is just multiply and solve, except I did mess up in one little area that I want to make sure that I fix real quick. Remember, 4 times the square root of 3 is the long side, okay? But our base is all of that, so we have to multiply that by 2. Okay, so this is actually going to be 8 times the square root of 3. 8 times the square root of 3, because this is half of it. That's going to be all of it. Okay, so now we can go ahead and multiply all of these. We're going to take our calculator again. We're going to do 8 times the square root of 3 times the square root of 3 times 4, all divided by 2. That's multiplying it by 1/2, and we get 27.7. So the area of the triangle is 27.7 units squared. Okay, and then this last step, the only thing that we have left to do is just subtract these. We're going to take 67.0 minus 27.7. We're going to have to borrow a little bit. We're going to get 39.3 units squared. Remember, all we wanted to do at the very beginning of this lesson was to try and find the area of sectors, and I think we've done that.